Alright, so today I want to show you guys how to use a calculator in order to draw a scatter plot and be able to find a line of best fit and then be able to make some calculations with that. What I took as an example was a problem that talks about the demand for a pair of jeans versus the price that we're looking at. So the problem says the marketing manager at Levi Strauss wishes to find a function that relates the demand D for men's jeans and P, the price of the jeans. The following data was obtained based on a price history of the jeans. And so I've got that here. Basically the price here, this is how much you're spending per pair. And then over here you have the demand based on the price that's influencing that. And so as usual, whenever you're looking at any sort of table or data, you want to identify the independent variable. What is the input? What is going in? So that would be the price. And then what is coming out of this? What are we looking for out of this problem? So this is the demand. So anytime we want to use a calculator in order to draw a scatter plot, it's important that we make sure that we turn on that function first. And so in order to do that, we need to hit second. And then under y equals, there's a, in blue lettering, there's stat plot. And so you're going to see here that you have, different plots that you can put on. If you're just doing one of them, you can go to plot 1, and you want to make sure that you turn that to on and select that. Okay. And so you can, determine the type. You can, make them all fit together in some certain way, making a bar graph. We're just going to select kind of the normal dots here. And then X list, Y list, that's just where you're putting in the table of data. So after you've done with that, you've turned that on. You can go ahead, second quit that. And then now you need to put in the data that you're looking for. And in order to reach that screen, there's the button called Stat here. So if I hit Stat, then it'll take me to this screen. And so Edit, I hit Enter, and that's where I can put in all my data. Now, if you have data that's already in here, the easiest way that I've found to clear this is to go all the way to the top, hit Clear, and then you have to hit Enter, and that will clear like the whole column. Here, you can also hit Clear, Enter, clear the whole column. And now I'm going to start entering my data, my independent variable here, my input. I'm going to start entering that into table L1 or column L1. And so I'm just going to go ahead and do that. 20, enter is my first point, 22 is my second, 23, 23 again, 27, 29, and then 30. So those are all my inputs. And then I'm going to go right over to my outputs here, and I'm just going to match up all of them, and maybe at the end just kind of check to see how things are going. So I've got 60, 57, 56, 53, 52, 49, and 44. And it looks to me like they all kind of line up properly. Now, if I just want to see the graph of, these points here, I can go ahead and hit graph. Now, as you can see, there's an issue here. Why am I not seeing my points? Well, first off, we have to be able to zoom into those points. And the easiest way to do that is to hit zoom. And then you're going to see here zoom stat under number 9. And so if I go to 9, it automatically puts all of my points there. Now, what can I kind of figure out from this trend? Remember that over here on my y-axis, I have the demand that I'm looking for, and over here on the x-axis, I have my, price. Well, if you look at the trend of this data, it's trending downwards. It looks like as the price increases, the demand for this, pair of jeans at this price seems to decrease. And so when we're thinking about trying to create like a line of best fit for this, we can think of maybe a line that has a slope that's negative, a line that goes down here. And so when we actually go to calculate this function, we're going to want to think of that to make sure, like, does this make sense? Is this matching up with what I'm thinking about? And so if we want to calculate the line of best fit, we need to go back to our stat menu, and rather than edit, we need to scroll to the right and go to calc. And you're going to see here all these different options. Now, it's at this point you need to figure out, does a line make sense for what data I'm looking for, or should I use some other sort of model? But since we see here that the data probably could be, a line probably could be used for this, we're going to use what's called a linear regression function or calculation. And so you're going to find two of these, but the best one to use is number 4 here. You can see ax plus b, just because that's much more similar to y equals mx plus b. So we have our slope first, and we have our y-intercept next. So that's going to be easier to kind of find. So I'm going to hit enter. And all it is asking us here is just, what list are you looking to take from? So x list L1, y list L2. We already kind of set those up in that way, so we should be fine. Now I could go all the way to calculate here, but imagine that I want to be able to see this line graphically as well. And in order to do that, it's a little tricky. I need to scroll down to where it says store regular equation is what I'm assuming that means. And I have to tell it where to store that graph. So when we normally go to the y equals graphing screen, we usually input into y1, y2, or whatever equation we're looking to graph. Well, this is going to take this equation and it's going to put it into y1, or wherever we want to put it. And so in order to do that, we need to hit the VARS button, and we need to scroll to the right under yvars, and we need to select function. And you can select whichever function you want it to be stored in. Y1 is probably most easy right now because we don't have anything there. So we're going to store whatever we calculate out of this into the Y1 section of our plot. So let's go ahead and let's calculate this. All right, so it's telling me y equals ax plus b or mx plus b. It's telling me my slope is at negative 1.336 about, and my y-intercept is at about 86.2. So it makes sense. Our slope is negative. This line that we get is going to be trending down. So let's just go ahead and let's write that. Y equals negative 1.3, and I'm actually going to round off 2 decimal places, negative 1.34, and that's going to be x plus 86.2. Okay, so that's the equation for my line of best fit. And if I want to see this on the graph, I can go ahead and I can just hit graph. And you can see that it's basically selecting whichever line it thinks best fits this data. All right, so what else can we get from this? Well, first off, by being able to create this trend line, what we can do is maybe try to make predictions around this data, because you see that we've just got some different data points. We're trying to create a trend here. We're trying to predict, let's say, we see that when the price is $23 per pair, we have some different data points here that we've gotten. Well, what if I want to figure out maybe, if my price is, $24 per pair, what might I predict that to be? Where can I maybe try to optimize my demand, my profits? I mean, sure, it'd be really nice to be way up here where the demand is high, but more than likely, I think in a real business scenario, you're probably going to be ending up maybe somewhere in the middle. Okay. So some of the other things it asks us here in this problem, it says, what is the domain of this function? Okay, so domain is all the possible inputs that we can think about here. And when we think about this problem, well, the price that we can potentially have, we could have something that's free, even though that doesn't really make sense for any sort of profit. But that could be a scenario. When the price is $0, you would say maybe that the demand is really high, and you could kind of maybe figure out some trend there. But we can say that maybe our starting point in terms of this data, negative money, does not make sense. So we could have a domain that starts at 0, and I'm using interval notation, so that bracket means that I'm including 0. And then we have to think about this graph and where it makes sense. Well, eventually the demand is going to be none, right? There's going to be no demand for this item at a certain price. We can't have a negative demand. That doesn't really make sense. So we're looking at really where this line here is going to cross the x-axis. Well, how do I find that? Well, I need to figure out where the output is equal to 0. Well, if I figure out where the output is equal to 0, I'm basically solving this equation for x, okay? And so what I'm going to do is I'm going to subtract 86.2 on the other side. And then you can see here, in order to find x, I need to divide that by negative 1.34. Okay, and the negatives cancel out. And so I'm going to end up with, and I'm going to clear out of this just so I can so I can calculate this. 86.2 divided by 1.34. Okay, 64.33. So at about $64 is when the demand for this price is going to be at 0. And this problem's a little outdated, so, unfortunately prices have gone up a lot. But in this hypothetical situation, what it's saying is if the price of this pair of jeans is a little over $60, that the demand is going to be equal to 0. And so we can look at our domain here as being between 0 and $64.3. Okay, how many jeans will be demanded if the price is $28 per pair? Well, all that's really asking us is, what is the demand when the price is $28? And so we can use this function here, this equation. We can input $28 in for x, and we can figure out what the demand is coming out of it. So let's do that. Negative 1.34 times 28. And then plus 86.2. So if we were to set the price at $28, then what we would have in terms of demand, so the number of pairs we think we might sell per day, is going to be, it looks like, a little under 49. And that makes sense because when we created our trend line, we looked at this data point here, we found something very close to it. And so, it wouldn't make sense if this was like really low, or, like 40 or something like that. It wouldn't make sense if it was really high into the 50s. So that's how you can solve, a real-world problem using your calculator and kind of creating a scatter plot here. You could do this manually, but it does start to, become a little bit tedious in terms of graphing this. So if you know how to graph and you're comfortable with it, using your calculator to, solve this type of problem is beneficial. Now, the last thing I just want to point out is that if you're doing any other type of graphing on your calculator, so let's say you do scatter plots, and then maybe the next week or even the next day you want to do a different type of plot. Well, you want to make sure that you turn off this stat plot here. So you want to make sure that you select that and you turn it off, because that might cause problems with your calculator whenever you're trying to graph. And then when you go into your window here, you may just want to clear out that line of best fit that you had already created. All right, I hope that helps, and be sure to subscribe, and you should see more videos like this kind of in the future. And if there's any types of questions that you might have, just feel free to leave those comments below. All right,